Hello everyone, this is Roshan. I have 11 years of experience in IT and I'm currently working as a DevOps technical lead. So in today's session, we are going to discuss about what is cloud computing and what is AWS. So to start with, so we need to understand about our like previous technologies before moving to cloud computing. So in the initial stages, okay, so this is just a technical roadmap. Take an example in 1990s. This is about how we developed application and what technology we used, and then how it is developed as virtualization, and then how cloud computing came. So we'll see in that flow. So in 1990s, to run any application or to start any startup companies, we need physical servers. Okay. So these are all hardware example, HP or Dell or IBM hardware, whatever it is. So in this hardware, we'll install a single operating system and we'll differentiate them with web application, DB application, or backup servers, etc. So these are all operating system. Java, DB, or any backup server for the web application. Okay. So we'll discuss about the drawbacks of this environment. So we call this environment as a physical environment. Yeah. So this is the like overview diagram. So in this physical environment, let's start with this about the drawbacks. Drawbacks are the first drawback is cost. Okay. So each server at least will cost minimum 3 lakhs to maximum it will go with the resource we are going to purchase. Okay. So the cost is a very big problem in this physical environment. And the second one is resource wastage. So what is resource wastage? Take an example. We are having a spec for this particular server, which is RAM is 8 GB, processor is 4 core, and hard disk, which is 500 GB. Okay. So we cannot utilize the full capacity of RAM. In case if we utilize, definitely our machine will slow down and we cannot use it. Okay. So mostly what we are doing in real time. So we'll use 50% of RAM and we'll keep 50% ideal. Like we'll use any monitoring tool to monitor them and it will send us alert in case if it is crossing the threshold limits. Okay, so this is what I'm mentioning about the resource wastage. We cannot fully utilize the resource we purchased. Resource sharing is not possible. So in case if this server is having 4 GB of RAM free, okay, so this cannot be shared to another server in a live environment. Okay, they will not allow us because like removing this RAM from this cabinet is a difficult task. Like we need to remove these servers from the rack and we need to remove all the cabinets and taking out the RAM is a difficult task. Okay, so resource sharing is not possible. So to give you an idea, like how physical service looks like. See, yeah, it will be in racks and it will be very difficult for us to remove them. So we'll discuss more about what are these servers and what are the features of these servers. Okay. The fourth point is OS installation time. So since I showed you how a physical server looks like, right? So physical rack server. So it will be very like difficult for us to mount them in this rack and connecting all the networks. Okay. So to do all this step from the scratch, the OS installation time, at least it will take 2.5 to 3 hours. Okay. And the fifth point is space. Okay. So definitely, if you have more customers, you need to have more machines and you need space to accommodate them. Okay. So space is a very big issue in case if you have more number of servers in your organization. Sixth point is electricity. Okay, so obviously you need to supply both AC and DC current. In case AC failed, we'll get a backup from the DC current. So finally everything is ready. So these are all the drawbacks in physical environment. So next is physical environment. We got a technology called virtualization. Okay, it was developed in the year of 2000. So in virtualization, so I just show you an overview diagram. So it looks like this. You'll have a physical server. On top of this physical server, you have an hypervisor. Then you'll have the operating system running underneath it. So to explain you in this way, see here, each OS required single servers. Okay, but in virtualization, in one single server, they used a hypervisor technology called ESXi. So hypervisor is a common name for whatever technology which does virtualization. Okay. So they used ESXi hypervisor. On top of this ESXi, we can install all these multiple OS in a single hardware. So this is the difference. See, I can bring Java inside database and backup servers. Okay. So now we'll discuss about the advantages. So since here we required three different hardwares, but here a single hardware is enough. So obviously the cost has been reduced. Okay, then resource-based and resource sharing both solved actually together here. Let me explain how it is. So since we'll see the same scenario here. In this Java server, the same 4 GB RAM is free. So in this case, we can easily share this free space to other operating system because underlying hardware we have is a single hardware. So this guy decides like whom to share the resources and he monitors which operating system is having free spaces. Okay, it is very easy for us to share the resources. So in case, so if we share, definitely we are solving the resource wastage problem. And in OS installation time, so here maximum it takes up to 30 minutes to, because we don't have any issues with the racking or like mounting the servers, etc. Okay, so the servers will be on ready and it will be very easy for us to create the operating system. And definitely space and electricity reduce since we are reducing the number of hardwares. Okay, so this is what virtualization concept is. So then we got a concept called cloud computing. So it is started booming in the year of 2010. Actually, AWS developed in the year of 2006, but slowly, like everyone started using it from 2010. Okay, so what is cloud computing? What they're actually doing. So even though if you need a virtualization in your organization, definitely you need to purchase the VMware license and you need to like you should have some space to have these single hardwares. So AWS is coming with a proposal of, see, yeah, this hypervisor belongs to the VMware company. ESXi, actually the evolution of ESXi is Elastic SkyX integrated. It is an OS which do virtualization, like which creates multiple OS in a single hardware. Okay. So a cloud computing, it's similar to VMware, okay, but the only difference is We don't need to maintain anything in our data center. Okay. So the same concept. So what they are proposing here, right? See, we are having our hardware. So they are not using this ESXi. They are using HVM hypervisor. Okay. So here what they're proposing is like they are having all the hardware and all the setup. So they are just using internet as a medium to give these machines to our organization, or even you can easily work from your home with a laptop and you can connect all the servers through AWS. So this is the success formula of AWS. So they use only internet as a medium to give the servers to users and the organizations. Okay. So with this technology, actually, we have reduced like plenty amount of cost. Take an example, in case if you are maintaining this VMware, and I'm just giving a rough example, and it costs at least per month 1 lakh. In AWS, it will cost only up to 5,000 to 10,000 rupees. Okay, so there will be huge difference in AWS because it is a public cloud, so anyone can like purchase the cloud machines. Okay, so we'll discuss about the advantages in AWS. The first advantage point is OS installation time. So they are having an on-demand ready concept. So with this concept, we'll get the OS within 5 minutes. And it depends on the region, but maximum it will take up to 2 to 5 minutes. Okay, we'll get an OS quickly in AWS. And the second point is, as I told you, we don't need to care about the data center. Okay, actually, we can get rid of the data centers. Data centers are nothing but they are rooms with servers, with network, storages, etc. And third, actual main point is auto scaling feature is available in AWS, but not with VMware or physical environment. What is this auto scaling? So discuss about this auto scaling. We need to know about what is load balancer in IT. Okay, actually load balancer in networking. See, take an example. We are having a website which is flipkart.com. Okay, so they will not have a single web server. They will have identical web servers, like the clone of the same application servers, because one server can handle up to a count of, take an example, this server can handle up to only 100 connections per second. Okay, so even though your website is good and everything is fine, but the network capacity is only 100 customers. So they will create replicas and they will share the next set of customers to other machines. So how they are sharing? They are using a concept called load balancer. Okay, because each machine will have different IPs. We cannot give different IPs to customers. They should have a common IP. So LB itself will generate a common IP that will be given to customers, and depends on the load, it will share the user connections to the underlying machines, which is the web servers. So this is what load balancer is. These are all OS operating systems or web application, whatever it is. Okay, so this LV is available in physical and virtual environment, but how? What is this auto scaling feature? Okay, so we'll take an example. You know that today you are going to initiate a concept called Big Billion Day, Flipkart Big Billion Day. So you're expecting that you will get 3,000 customers exactly at 5 p.m. Okay, so you have prepared the three machines, and each machine can serve up to 1,000 customers or 1,000 connections per second. Okay, so like the time has arrived and we are going to initiate the Big Billion Day. But what in case if you get 6,000 customers? So it is unexpected. Okay, you plan something, but you got 6,000 customers. So in physical or virtual environment, the machine creation time itself will take up to 30 minutes or 2 to 3 hours. So it is not possible to serve the customers right away, whoever logs in. Okay. So in this scenario, it will be very difficult for us to increase the machine and to serve the customers in physical or virtual environment. But in cloud computing, you know that the machines will be created in 5 minutes to 10 minutes. So in this situation, we have a concept called auto scaling. That feature will automatically build the machines. Okay, depends on the load and it will attach it to the load balancers. So this is a very highlight feature in cloud computing, not only with AWS, like all the cloud computing is having the same feature. So this is what auto scaling is. Okay, so if load is high, the machine will increase. If the load is low, the machine will decrease. Okay, so this feature is called auto scaling. Okay, so yeah, so this is what a cloud computing is. Cloud computing is nothing but we have few providers like not only AWS, like example, we have AWS, Azure, GCP, blah, blah, blah. So these three are the market leaders currently. Okay, and the AWS is the like still holding the number one place in cloud computing. Okay, so this is nothing but these guys are having a data center and they are using internet as a medium to share the machines to us. This is what cloud computing is. Okay. So now we'll discuss about what is the types of cloud. Okay, so now we got to know what is cloud computing. So now we'll discuss about what are the types of cloud. So there are three types of cloud is available. One is public cloud, private cloud, and hybrid cloud. So we'll discuss more about public cloud. So public cloud is nothing but like they give the machines to like all the uh, peoples or all the organizations who requires it. For example, AWS, Azure. See, I'll give an example. This is our organization. This is some other providers who is giving public cloud. We are using internet as a medium. Okay. So if you have your entire environment in public cloud, okay, let's say, or take an example, web you are building in public cloud, you are getting help from AWS or Azure or GCP, Google Cloud platform. Okay. So if you keep all your environment and application in public cloud, that is comes under public cloud category. Okay. And what is private cloud? Private cloud is like you are not keeping anything outside of the internet. You are keeping all your data inside your organization. Even in AWS, if you have a dedicated resources or dedicated machines for you, that is also can be tell us private cloud. But the actual concept is keeping everything in your organization, matches it very well. Okay. So if you want to build the same cloud-like environment in private organization, like you have a solution called OpenStack. So OpenStack is an example to create your own private cloud. Okay. And you can keep all your applications inside your organization itself. This is an example of private cloud. Okay. So now what is a hybrid cloud? So hybrid cloud is nothing but it's a combination of public and private cloud. Okay, which means you are keeping some set of data, so non-critical data in public and critical data in private. So this combination is called hybrid cloud. Okay, this is just an example. Okay, it depends on the company, the scenario will reverse, but I'm just giving an example. Like non-critical applications or non-critical data, I'm keeping it public cloud, and critical application data, I'm keeping it in private cloud. So this is called hybrid cloud. Okay, it's very simple. And the next concept we have is services of cloud. Okay, so IaaS, PaaS, as infra as a service, platform as a service, and software as a service. Okay, so yeah, we'll discuss it in a bit. So IAS is nothing but in later on in other sessions, we'll see more about these two concepts, IAS and SAS, and I'll tell you where these concepts matches. So now for our understanding, so IAS nothing but in AWS term, I'm telling, we will in AWS we will not get any access to the physical environment or nothing. We get only the OS access. Okay. So in IAS we'll have full control to operating system. Okay, then we have full control to whatever software we can install, and we have full control to develop on top of the software. This is what IAS is. Will be getting OS control. We'll be getting what app we need to install, and we will be getting what we need to develop. Okay. In PaaS, we'll get only access to the runtime, which is directly the app. Then we can develop on top of it. Okay, we'll not get OS access. See, in this OE, yeah, they have depicted like this, right? In this OS, we'll be having multiple applications. Mostly, I'm going to use Java. Then why I need the entire OS? In these concepts, PaaS will help us. Okay, so in the PaaS services, you are going to use only Java, then I'll give you only Java access or Java application connectivity access. If you're going to use only Python, then I'll give you Python application connectivity access. Okay, this is what PaaS is. Okay, instead of wasting the entire OS. And SaaS. SaaS is nothing but which is a developed application. Okay, take an example. I'll give you one simple example. You are running a school. Okay, you need a student application like you need to register his attendance, you need to register his marks, and whatever like his details and everything. Okay, so you are approaching some company. If they develop for you and if they deliver it to you, then it is called as SaaS, like which is a developed product. You will not put any effort in this. You can be a SaaS provider. Okay, so you will either use IaaS or PaaS technology to be a SaaS provider, but mostly SaaS means it's an end user application where we are going to use a developed app. So Salesforce, Gmail. So these are all examples of SaaS. Like we are just using them. Okay. So this is what you need to understand about IaaS, PaaS, and SaaS. Okay. So this is all more about the cloud computing. And in the upcoming classes, we'll kickstart with chapter one, which is easy to elastic compute cloud, nothing but operating system. What are the operating systems available in AWS and how we create them and connect them and how we host our web application on top of it. Okay. Additional to this first session, I will also like to discuss something about DevOps. Okay, because we all know that the DevOps is currently emerging in the market, and this technology is really good. Okay, so in case if you're completing AWS in future, definitely you will need to know at least some of the DevOps tools. Okay, definitely list some DevOps tools in your application. So we'll discuss a little about this DevOps. Okay, so what is DevOps? DevOps is nothing but we are going to connect multiple tools, okay, multiple softwares to maintain the software lifecycle management, which means from the release to delivering it to the customer. Okay, the entire flow we are going to automate it by using some tools. Okay, so before DevOps, let us discuss what are the problems, and now we'll see about how DevOps solve the problem. Okay, so these are all just a simple example tools for DevOps. Okay, so here we are going to use in case in future if you are going to take DevOps session from us, then like we'll add the most important tools which is needed in the market in our course. Okay, so we'll discuss about how before DevOps what are the problems, and we'll see how DevOps solve the problem. So before DevOps, if a developer writes a code, okay, so he cannot simply keep the code locally in his system. Okay, he should have a centralized repository. Okay, so yeah, in DevOps, like we have a tool called Git. There, it will maintain all the repositories. So we'll discuss about, okay, he developed something. Okay, so before the development itself, in case if you request a system or server, okay, from system admins, Okay, so definitely it will take some time for them to build this machine and to deliver to the developers. Okay, then after that, what will happen? They will give the developed application to testers. Okay, so if this chain breaks anywhere, because mostly this chain is a manual chain. Okay, if this chain breaks anywhere, then everything will be started from the beginning, or we will definitely face a time wastage there. Okay, so this is what the DevOps solved. We don't need to wait for anything. So in DevOps, just simply write the flow. It's a kind of an infinity loop. Development and operations. Okay, so here we are having a tool called Git. So developer will develop something and he will upload the code to Git repository. So Git is nothing but a plain repository. So whatever raw code is there, we should know to compile it. So take an example, we are uploading Java code, which is pom.xml code, and we should use Maven tool to compile it. Okay, so compile is nothing but like making the software out of the raw code. Okay, just packaging the raw code as a software. So once Maven compile the package, okay, we'll use Jenkins. So Jenkins is a very important CI/CD tool in DevOps, which is which do continuous integration and continuous deployment. Continuous integration is like integrating all these required tools, Git or Maven or Gradle or Ant, whatever tools required for this entire operation, it will integrate them. And finally, it will deploy them either in AWS or Kubernetes or physical environment or virtual environment, wherever it is possible, it will deploy it. Okay. So Jenkins is a CI/CD tool which connects everything to make this operation smoothly. Okay, so the once it is compiled, so Jenkins is having the capacity to move this code either to Nexus, like the package to Nexus, because Nexus maintains all the artifacts, packages, otherwise known as artifacts. Okay, and also in case if you are using Docker, okay, Nexus is also kind of repository. Git is raw code repository. Nexus is nothing but this packaged repo, compiled repo. Okay. So then we have Docker. So we all know about Docker. Docker is a very important tool in the current market. Okay, this is nothing but as I told you before in past, right? So in past we are going to use only Java. Same Docker will also do. It's a kind of a PaaS-based technology. In Docker, we'll have an operating system. On top of the operating system, we'll install Docker. Okay, we'll be having a OS, only Linux OS example. On top of Linux, we are installing Docker. So Docker capacity is like, it will not waste the entire OS. Okay, in case if you need only Java, it will build a container for Java. So in this container, you will have only Java dependencies and Java related library files. Okay, so you will not waste the entire OS. This is the concept of Docker. Okay, then if you want some other application, two to three JavaScript, imagine you cannot install three versions of Java in your single machine. Okay, so each will be different versions, and it will be very difficult for you to switch to each versions in case with the environment variables. But in Docker, you can run them separately. Okay, that is the advantage of Docker. Okay, so these are all called containers. Java container. The simply instead of wasting three different operating system for three different Java applications, you can use them in single Docker. The three different I have mentioned about the versions: Java 1, Java 2, and we can even have a website or like any HTTP websites or something different software. This is what Docker is. Okay, so it will be very easy for us to save the resources if we use Docker. Okay, so like out of this package, we are making them as a container in using Docker. Then the CD part. So once the container is ready, okay, then it will be deployed either in AWS or Kubernetes. Now the latest trend is Kubernetes. AWS we discussed. Okay, so what is Kubernetes? Kubernetes is nothing but we have two OS here, and we have Docker and same containers are running. Okay, so what in case if this one Docker is down, suddenly any power outage or any software issue, something happened, and this entire Docker is down. So what will happen to these machines? Okay, so these machines will also go down. Since take an example, we are running any Flipkart website on top of this Docker, then definitely we face downtime and we lose profit. So to manage this failover, we need a software called Kubernetes. Initially, it was Docker Spam. Actually, it was very famous, but Kubernetes is like stability wise, it is really good. And now this is the like major tool in the market, like market kind of market leader. Okay, just to manage your Docker containers. Okay, so there are many components in the Kubernetes, master node, worker node. While we go to DevOps, definitely I will explain with that. Okay, so this is what Kubernetes managing your Docker and the failovers. So in this case, if you have using Kubernetes, if currently this OS is down, it will move the machines to healthy OS. Okay, so this is what Kubernetes is. So I have deployed, and after deployment, we use some configuration tools. Example, Puppet, Ansible, Chirp. These are all just to manage your configuration. See, if you need to run your application or if you need to do some configuration changes, definitely you cannot do it manually. Okay, so in case if you use any configuration management tool, even though if you do some manual mistakes, that tool will help you to revert back to the actual configuration. Okay, so that is also one important tool in DevOps. So far, how many tools we discussed? Tool number one is Git, Maven, 2, Nexus 3, Jenkins 4, Docker 5, AWS 6, Kubernetes 7, and Ansible 8. Then, in case if you want to do testing, it will come in this phase. In case if you want to use Selenium before deployment, if you want to test this application before packaging, then you can use test cases here. Okay, that will be included by the testing team. After this, definitely for us, we need a monitoring tool to monitor them. Okay, then again we'll plan for new deployment. So monitoring tool example, now the famous monitoring tool are Prometheus. So we'll see this in our session. Prometheus, Grafana, Alert Manager. Okay, so this is the DevOps entire flow. Like when you trigger the job, so automatically it will build, like it will monitor, and finally again we'll plan for the next development. Okay, so like we need to study about these. These tools are very easy. It's not like the complete coding knowledge is required for this. It's very simple. If you follow my courses itself, more enough for you to easily practice them, and like you can easily pursue your career in either DevOps or AWS or Kubernetes. So we'll cover like everything in our session. So it depends on your requirement. Okay. Yeah. So yeah, thank you so much, and we'll meet soon in our next uh, classes and videos. Thank you, everyone.